Okay, we're going to look at another example of empirical formula, but this one is going to be a little bit more challenging because you're not told the masses of each element right off the bat. So this question tells us the elemental analysis of an unknown organic compound returns the following data. So there is a 64.6% of carbon, the percent composition for hydrogen is 10.8%, and the percent composition of oxygen is 24.6%. What is the empirical formula for this compound? So something we will recognize immediately is we don't have masses, but we need them. But whenever you're given a percent, since percentages are just fractions out of 100, we can always assume a 100 gram sample for a question like this. And we can do this because percentages are just fractions out of 100. So if we assume that our total sample is 100 grams, we make the math there much, much easier for ourselves. So we will assume a 100 gram sample. Now our next step is we're going to have to find the number of moles for each of these elements. So we know that if we have a 100 gram sample, again, we're going to find the masses pretty quickly. So the mass of the carbon, 64.6%, we can just say that that's 64.6 grams because we're assuming a 100 gram sample. The mass of the hydrogen, 10.8 grams, and the mass of the oxygen, 24.6 grams. Okay, so now we are going to have to figure out the number of moles for each of these elements. So the moles of carbon, again, just as a reminder, we know that moles equals mass over molar mass. We had lots of practice with that before. So 64.6 grams divided by the molar mass of carbon, which is 12.0107 grams per mole. I'm just going to set up all my equations so we can do this quickly. The hydrogen, 10.8 grams of hydrogen divided by 1.00794 grams per mole. And then for oxygen, it is 24.6 grams divided by 15.9994 grams per mole. Alright, so then we will plug these numbers into our calculator and be able to determine the number of moles for each element within this compound. Alright, so I just quickly did that off camera to speed things up a little bit. So that's the number of moles of each element that we have in this compound. Just like before when we're finding the empirical formula, we want mole ratios. So we're going to divide each of these numbers by the lowest number of moles to find the relative proportions of each element within this compound. So that means we're going to divide each thing by 1.54 moles because that's the moles for oxygen, that's the lowest number of moles. So if we want mole ratios, we'll say 5.38 moles carbon, so then when you type all of these into your calculator, you will get the relative proportions of each of these elements. So I'll just do that quickly. Alright, so I've determined the relative ratios or proportions for each of the elements within this compound here. So our next step is to write this in an actual chemical formula, and just by inspection we'll see if it looks okay. So for the carbon, that would give us C 3.49, and for the hydrogen 6.95, and then for the oxygen 1.00. And now you're probably thinking, okay, well there's decimal places and that doesn't seem right. If you're feeling that way, you are correct. Elements only ever combine in whole number ratios. So our first step is we're going to have to find another equivalent set of ratios that can get each term out of these three as close to a whole number as possible. So we see here that there's a 3.49 and this is a 6.95, so it's easier to bring this term to a whole number simply by multiplying by 2. So that's exactly what we're going to do. We're going to take all of those numbers, multiply them by 2. And then when you do that, you will get a formula of C 6.98, H 13.9, O 2.00. So it's still not perfect because we have decimal places, but we are much closer to all of these being a whole number compared to what we had originally. And because all of these are so close to a whole number, we now can just round them off. So now we can say that the empirical formula most likely is going to be C7, H14, O2. And then that there would be our empirical formula for this unknown organic compound.